Cool. All right, got your notes out. Yesterday, I had hoped we could do the 0-1 sets because that was just, I mean, it's like 3 examples. It's just terminology, but that's okay. If we got to do a side quest, we got to do side quests. Last semester, that's that's why they didn't get 2 of our 8 units. We had to do that many side quests. I would rather that you know the absolutely critical stuff to move on than, you've heard the phrase a mile wide and an inch deep, right? Where you just.
I heard that yesterday and I dropped the class.
Yeah,
You did? Yeah, no, I couldn't do the group quiz. I'm gonna be honest. If it takes like 20 minutes to do a quiz with 6 questions, I'm not, no. I'm planning on dropping it too.
well, our tests in here are usually 6 questions. It usually averages 20 to 30 minutes for kids. So, for those of you that are getting into Remind and send the stuff, that's great. Honestly, it's nonsense. It's if you've ever done any personality quiz of any kind, if you understand the content behind it, and if you understand how self-selected responses work, those of you who have done self-selected biases in statistics should be at the end of Algebra 1 and 2. You know that you can monkey with tests to make them look however you want. Um, an example would be there's a particular kind of test that someone in this room shared with a group, and I got past the maximum score on it just because I know how the test works. Like, past the maximum score. So, all of that aside, it's still just fun because I want you to just think about what you had. Basically, I am a dork. You're going to have to hear dorky things in here. Peace, prosperity, everyone works together, but also law, order, follow rules. Everyone's a blank slate. It's about perfecting the self. It's about learning. It's about being intelligent. It is about progress. Selfishness, good and bad. I take care of me at the cost that I am willing to pay. That might be at someone else's expense. It might be at mine. I deem it worthwhile. YOLO, passion, freedom, impulse. Everything is natural and you just go with the flow. That might be good, it might be bad. There is no inherent morality in it. It is all just, that's the way life is. And you start mixing those things together, and how many of you got, for example, usually we'll see kids who come from stricter families and maybe religious backgrounds will get blue-white, Azorius, because it's all about, I know what is better than you do, so I am going to enforce my rules upon you. My ADHD kids, red, blue. I want to press buttons and see what happens. Okay? Those who lean towards neurodivergence, particularly autistic, blue, white, red. Jeskai, very common. A sense of morality, this is how it's supposed to be. I want to be the best that I can at it, but also ADHD go burr. If we have anyone in the room who got Grixis, red, black, blue, you're essentially an evil genius. Okay, looking to dominate the world. I heard a couple of kids talking. Naya, red, green, white, is kind of a, it's all about living in the moment and doing what's right for me at this time, but I'm okay if it doesn't work out. Did we get any gruel? Red, green. I had one class a couple of years ago where there were like 5 girls who all got red, green. Red, green is like survival of the fittest. I'm gonna smash your face. Like, the strongest survive, screw everyone else. And there's like 5 girls in there like that. It was pretty funny. I hope we don't have any red black. Red black is Rakdos. Those are essentially sadists and masochists. Pleasure at the cost of pain, whether it's mine or someone else's, I don't care as long as it's funny. So you get to learn a little bit about someone. Anyone get white, blue, black, Esper?
I feel like I wouldn't trust that.
That fits. Um, that is that is cold, calculating. I will do what is best for me at the expense of other people, or if I deem you worth my attention. Yeah. Red, white, my homie. Red White is the Boros Legion, the soldiers of Ravnica. It is all about I have morals. This is what is right, and I will punch your face in to make sure that you follow those rules. Because this is what is right. I know it is right. I am impulsive. I don't care what you say. Do the right thing, or I kick your face in. So it's fun. It's silly. The main thing is I just want to make sure that y'all can access Remind. I want to make sure that you can send me stuff on Remind. That means you can take a picture and send questions if you have them. And you can access our Google Drive folder. Okay? That's all it is for. Honestly, you could just poke one question and send the results to me and whatever. I just want to have proof that you can engage in the class. Okay? It's something silly that makes nerd brain go burr. So, we were not able to go too far with this, but that's okay. I honestly didn't expect that we would get it at all yesterday. So here we go. Oh, before I go into this, did anyone just kind of explore in that Google Drive folder and see other stuff in there that might have interested you? If you go into not in the Wiley, remember there's Wiley and Glencoe, the two different curriculum in that folder. If you go back into the Glencoe series, I have all of my old Holy Sheets in there. I know that some of our teachers, I think Mrs. Work still gives these out in geometry or something like that. In all of them? Okay. So these are my notes for that chapter, my notes for that section. It's usually 1 or 2 pages, condensed version, cliff notes, kind of like if you've ever bought one of those laminated super cheat sheets for US history or for measurement conversions. It's like that, okay? If you want those, they all match with what we're going to be doing in class. And I tell you what, hot damn, that is a good thing to have on hand if you're going to be reviewing for an ACT or something like that. Here you go. This is everything that we're going to review for Chapter 0. Okay. Sets. We left off with, we got through these 4, right? We were okay with element of, sets have the little squiggle brackets on there. What we did not get to then would have been a little bit of definition. Universal set, earthing. It's all objects. Not necessarily within a set. Notice that the U there is in the box, whereas the A and the B are the circles. The circles are the sets or collections of objects. The universal covers everything. So maybe sometimes you'll have 1, 2, 3, 4, and 5 will just be like hanging out here. 5 isn't a part of those collections. It's not a part of those subsets, but it is a part of the universal set. Again, that's like Vanellope's deleted code hanging out over here in the middle of nowhere. The subsets, we kind of talked about that. It's a smaller collection inside of a larger collection. Or group, any grouping word. Smaller group inside a larger group. Complement. Notice the E in there instead of an I. What's the difference between a complement versus a compliment? Where's my English majors? Huh? Compliment. Oh, those shoes are cute. Complement. You need to have peanut butter with jelly, or else that's just weird. Okay. Compliment with an I is to provide positive feedback for something. Complement means it goes with. They go together. Peanut butter complements jelly. Fries complements chicken nuggets. Like stuff that just goes together. In the context of sets, the thing that goes with a set is the stuff that's not in the set. It's still there, it's just not in this group. Okay? So a complement is the opposite of or not in. Complement is shown two different ways. One of them I'm not a fan of, but we might see it from time to time in our problems, like in our examples here. So like set, if I wanted to know what set B was, just right here what I wrote. What is set B? Just 1 and 2. Okay. The complement of that can either be shown as B prime or not B. It can be shown either way. I don't like the B with a prime mark on it to mean complement, because where have we seen prime before? Yeah, say it loud and proud. In geometry, remember doing like triangle ABC, and then you'd move it, now it's triangle A prime, B prime, C prime? And then you'd move it again, now it's A double prime, B double prime, C double prime. Well, after this class, you're also going to see it again in calculus, because now that's the derivative of a function. So it has other meanings. I'm not a fan of using it in this context, but it depends on which textbook or curriculum we're working with. So they both mean complement of, and if I say complement of B, it's everything not in B. 3, 4, and 5. As long as it's not in B, it counts. So even though 5 isn't within A, it doesn't matter. It's outside of B somewhere. So it's the complement. Element of versus contained in, or not contained in. That's right. I never updated the PDF of this. Contains. Element of is kind of like a elongated E. Contains, you know what? I'll also put on there subset. Subset is a little elongated C. Contains is a big elongated C. Like uppercase, lowercase. And it's just symbols to get used to. It's probably been a few years since you've seen them. I find it really helpful with these sometimes to just make Venn diagrams. Are you okay with making Venn diagrams that have more than 2 circles? 2, 3, 4 circles, and having the overlap between them. Okay? They don't have to be artist renditions. Maybe your circle looks more like a potato. That's okay. But potatoes are yummy. That's how my people survived until the English tried to kill them. No? No one understands history?
No, I just couldn't laugh.
Okay. So, state whether B what A. What is that symbol? Okay, B is a subset of A. So I look at U, like the contains is big, like taller than the letters. If it's not taller than the letters, it's subset. Okay. You're not going to see contains very often. It's just one of those random things that I try to toss at you, and you're going to hear this all semester long. I'm going to just throw kind of tidbits at you sometimes, or I'm going to go through an example that isn't very relevant, but I still want to show you because it might pop up on ACT. And if you're in this class, then I'm betting that ACT and your score and scholarships and all that kind of crap matter to you. And y'all don't want to be one question away from I got the money, one question away from I got into the college. Okay, one question away from $25,000 of student loan debt. Okay, y'all get the super score now too. You know how ACTs work with that? Okay, probably our juniors, seniors do, not so much our sophomores. It used to be you'd take an ACT, you don't like the score, you take it again, and just whatever is your highest total composite score, that's what goes to colleges and they use. But about 5 years ago, they switched it up to a super score where now, if you get, say, you take your ACT right after pre-calc and you get a 27 on the math portion, not so hot in the English. And then you go and take it again next year, and now you get like a 24 in the math section because you forgot stuff, but you get higher in the English. They'll take the higher of both and put them together. Super score. Okay? And that didn't always used to be the case. So, anyway, again, universal set, B is a subset of A. If that is true, then everything in B has to also be in A. Is that true? Are both of these inside A? Cool. Go for the rest. Oh, you know what? I'll do C. So we got a little bit of both. Find A. They put the prime, so it means complement of. So this is going to be everything not in A. So I look at this, and say it's missing 0, 1, missing 2 and 3. Got 4, got 5, missing 6. Got 7, 8, and 9. So the stuff from the universal set that wasn't in A is not A, or complement of A. All right? So I do 2, you do 2. Do B and D, and especially our returning veterans, you know, I want you talking. I want you working with your neighbors. I want you arguing with them about who's right. Okay? Just don't punch your neighbor.
W is not about. Y is sometimes about. W has never been about. Never. Go back to English. Which one? Sometimes Y. What song?
You just making up lyrics now, dude. I mean, it's okay. I get it. Like the whole Benny and the Jets song, for years I thought it was electric boobs, not electric moves. Like I honestly thought that's what it was, and I was wondering why they could get away with that on the radio. So just I don't know where you're getting W from. These are fairly quick, right? E is a subset of D. Yes or no? But E's got 3, D's got 3, but it's not all of them. Okay, so that one's false. Complement of D. If U is all of my digits and D only got 2 of them, then the complement of D has got to be the rest. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So That's a really bad 4. That's it. Just making sure that we understand set notation, how they look. We got time here. Could you make the Venn diagram for this? A, B, C, and D, and E. Don't do it right now. That's going to take forever. 5 different sets. 5 different sets. So you would have 5 circles overlapping, and kind of like a flower petal in the middle of all of the intersections. If you can do that, then, and that makes sense for you, you should go to discrete math in college because you got the brain for it. Union, intersection, empty set. You know what? Over here we can do just a quick example. Here's going to be set A. Here's going to be set B. And here will be set C. And within them I will put 1, 2, 3, 4, 5, 6, 7. And then we'll have Vanellope out here, because all of this is considered to be the universal set. Okay, let's go ahead and draw us a triple Venn diagram like that so that we can talk about what unions and intersections are. Okay, so sets A, B, and C with digits 1 through 8. Everyone got them? You'll love when we get to conic sections and we're doing ellipses, parabolas, hyperbolas. Because for ellipses, we actually say draw the potato. All right. Union. If you know a upside down V like that is the and of the math world, then the and, wow, Papa Bear tired, or of the math world, union should look a lot like it, or for sets. Okay. It's easy to remember the union is a big U because, well, starts with union, right? Intersection would be the upside down of that, or reciprocal, I like that, because this means and in math world. So the intersection is, I just flip that big U upside down. That is the and of the math world of the sets. And empty set, we all better know that one because we've been using it for no solution for years. Okay? Be careful that when you do draw that, you have your line going diagonal through it, because this is empty set, whereas this is theta, Greek letter. Don't look confused. Theta is angles. You should have seen that back in geometry. Okay? When I'd say like the cosine of theta, it's the variable we use for angles. And we are going to see it again in chapters 4 and 5 in this class. Oh, also, these are all talking about sets. Don't ever do this. Don't ever put the empty set symbol inside set brackets, because brought to you by the Redundant Department of Redundancies. Don't do this, no, because that's like saying Mr. Sirman. That'd be like, Morford comes in here and you say, hello, Mr. Sirman Morford. Dude, guy. Like, it's because it means empty set and you're putting it inside of set brackets. It's like set squared. So it's overkill, right? Just this. That's all I need. In terms of examples of those would be like pink. If I ask for A intersect B versus A union B. Well, if I want A intersect B, it's got to be in the A set, but it also has to be in the B set. So it's that sliver in between. Okay. So I'd mark it as 2 and 7. Whoa, 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 whoa. But, well, no, not the 2. Not the circle. Frank, you rat bastard. Okay. A union B, on the other hand, is anything that's in A or B. Anything in there counts. So even though 1 and 3 are kind of floating off to the side here, they're still part of A and B. So 1, 2, 3, and the 7. Anything else? And the 4. One more. And the 6. Literally everything in there, whether it's connected to the other set or not, and you can just like lightly shade, especially if you're on a test. I just lightly shade the sets so that I know exactly where I'm looking at. I'm hypervisual, so that's me. It doesn't have to be you. You. What else? Sometimes you'll start to combine them with multiple operations. What if I did something really funky like C union not A intersect B? Okay. That would be the difference between Algebra 1 geometry and moving up, is if I can put multiple operators on it. So you got to take it step by step. Parentheses first, just like anything else. And it says the intersection of what isn't in A and it has to be in B. So not in A is all this stuff. But it has to be in B, and down to just 1 and 6. Okay? So I'll change my shading a little bit and say we're down to this. Okay, that covers this much. But then I say, or C. It can also be in C. Remember, it says or. So anything in C works. Because or be like that. So now all of this stuff counts. So even though the 7 and the 4 broke this condition because of the word or, we're still good. All of that stuff would meet this set. So we'll practice that a little bit. This would be like the most complicated one that you could see, at least in this class. Although I kind of want to make a 5 set diagram now and have a 5-6 operator version just to see who could figure it out. It'd be fun. Our hypervisual kids would. So down here, meet those conditions. R what S? Union means or. B, R what S? And C would be T intersect S. Go for it. Those three, write their sets. Compare with your neighbors if you got anything different on the list. You know, compare your guest list for your party. Dude, why are you inviting him? He sucks. He eats my goldfish. Now, if you're cool with them written out as lists like that, go for it. If you want to make a Venn diagram for it, you can. Frank. Yo.
What's the tilde? Like before A?
That's not it.
This squiggle?
That's not
I'm looking up at the previous
This?
example. Yeah.
Not complement.
Not. Oh, no.
prime and
It can be written either way, yes. T.
No, it's not.
Okay. So this is kind of what it would look like if I was drawing it out. R is 2, 4, 6, but 4 and 6 are also an S. So they would go like this. And S would also have a 5 and a 7. T, table of 1. And we're going to have, what else are we missing here? 3. It's kind of floating out here. 1, 2, 3, 4, 5, 6, 7, 8 is also floating out here. So if I were to draw it, that's what it looked like. I don't have to, but some of us are going to be more visual. R union S, anything that is in either one. So it's the sum total of the list. Don't repeat anything. Don't say 4 and 6 twice. It's going to be 2, 4, 6, or 2, 4, 5, 6, 7. There's no hard and fast rule that says you have to put them in numerical order. It's just nice if you do. R intersect S, on the other hand, whatever they have in common. And T intersect S, because they have nothing in common. Again, don't use brackets around it, just empty set. Okay. We'll do one more ugly. Let's do... Yeah, I'll just do that. What's that? Same with this. It's just I'm running out of spaces to write it. What would that be? Not R. Is that union or intersection? Okay, so anything that isn't an R or it's in T. It's not the whole universal set. Not in R. So outside of R. All that stuff. Or T. Well, T is outside of R. This is one of those cases where you can reduce down a set and say not R union T is just not R. Right? Because T is included within it. Now you'd still list out all those numbers, but it is possible to reduce sets like this, where they've got the same name, or they're the same object, but they might have different names. Again, that would be like, we did the binomial classification thing yesterday. What about this? What's this? It's a thumb. What else? It's a finger. What else? Phalange. I just like saying phalange. A digit. A button smasher. Okay. A sarcastic statement. Whatever, like, there are different ways to refer to the same object. Okay. This is just an example of it. Cuckoo. I said that 0-1 was quick. 0-2. Complex numbers. In Algebra 2, the whole lot of you got your very first ring. And I'm not talking about, like, oh, he gave me his class ring, we're going to be together forever. You're not. I'm talking about a mathematical ring. Okay? A mathematical ring is a mathematical structure that will constantly repeat itself. So maybe you want to like put it next to one of these, but the idea is we figured out. Words are hard. Math is important. We learned that I is what? It is imaginary because it is close. Square root of -1. Okay? Right? Okay, the square root of -1. It'd be a good idea. Don't have to. We learned that I was the square root of -1 because why is it imaginary? Square root of a negative. Remember, square root is asking what times itself makes this number. But what's a positive times a positive? A negative times a negative. It doesn't. I'm not ever going to get a negative unless I invent something. Okay? That's also the premise behind string theory. You just invent new dimensions. If I do that, though, and I square it, I squared. I squared is the square root of -1 squared, and we know that whenever we square a square root, cancel town, now it's -1. Okay? Now, I've eaten my feelings too much, so the shirt doesn't fit anymore. I have the Keeping It Real shirt. But, Goblin, world collapsing, all that kind of stuff. It's a shirt that says, I squared, keeping it real. Math puns, yay. Because I squared is still a real number. After that goes to I cubed. Well, I cubed, I'm just going to use these two and properties of exponents. I'm going to turn that into I squared times I. Right? Properties of exponents, I add exponents when they're the same base. So 2 plus 1 is 3. I cubed can be separated like this, which means it can be written as -1 times I, which means it's just negative I. I cubed is -I. And then what happens when I take I to the 4th? How could I split that out? I heard it. Someone said squared. right? I squared times I squared, well, that's -1 times -1, so that's 1. It's called a ring because it's going to keep repeating itself over and over and over and over. When I go to I to the 5th, I to the 5th can now be written as I to the 4th times I. Well, I know that I to the 4th is just 1. I to the 6th can be written as I to the 4th times I squared. So it's 1 times I squared. So it's I to the 4th times I to the 3rd. So it's I to the 4th squared. This idea that I to the 4th is 1 allows me to reset the timeline every time I cross a multiple of 4. So it just repeats itself, kitten calendar, it's just going to keep going. That's what makes it a ring. And that also allows me to skip ahead. What if I said something like I to the 53rd? I don't need to go around the circle that many times. Instead, I can break that into I to the 4th how many times I to the how many. What is a multiple of 4 below 53? As close as possible. 52. Okay, 4 times what makes 52? Okay, so I to the 4th to the 13th is I to the 52nd times another I to the 1st. Altogether, this is 53 I's, but I'm skipping ahead. Instead of going around the circle 13 times and then landing back here, I can just say, well, I to the 4th is 1. 1 to the 13th is 1. I to the 53rd is just I. Okay, that's a ring. Something that is only going to land on one of these 4 options. So, below that, right there. Oh, I actually used 53. Son of... Fine. What about I to the 39th?
I did it. I was ahead, man.
You did it at the same time.
How can you break up 39? I'm more interested to see if you remember your properties of exponents and you can break up I to the -18th.
See, that's the one thing I forgot. That's what I'm waiting.
Partner parent share. Don't just rely on that. It doesn't do everything for you. It'll damn near do your taxes. That thing is amazing.
For the 53, where'd you get the 4 from?
Because I to the 4th is 1.
Okay, so you'd use 4 this time.
So I want to keep using that because then I can keep reducing things down to 1.
That's the answer. I don't know. It probably is.
I bet you can do part A. I want to see who can remember how to do part B.
I'm pretty sure I remember.
Okay, wait, fine. I'll try to do it.
My brain is like destroyed my brain.
No.
It's not secret information. How far do we need to go today? Oh, oh yeah, we got plenty. We'll be able to get into 3.
I think I did it.
When you do
Are you
negative,
but also do you have to do anything else, or is that just like what it looks like?
Well, I know.
Yeah.
I
More.
know it'll go to
More.
decimals, but-
So I'm.
Oh.
This is
okay.
1
More.
to the 9th.
Wait, is it
So
divided?
I
So,
36.
1.
Yes,
Divided.
I was
It's
trying to
keep
show you
divided.
that.
1 to the 9th is 1.
Oh, okay.
What is I to the 3rd?
1 to 1.
No.
No.
I feel like a rubber negative.
What is I to the
Oh,
3rd?
negative
Yeah. So you have 1 times negative I.
Okay.
Is,
Negative I.
that's your answer.
Oh, okay.
Every single one of these, I to any integer power, should be one of those 4 things. I to any integer should be one of those 4 answers. That's what makes it a ring, is it can only be one of those 4 spots.
I divided by I.
Yeah,
It is?
yeah. Anything divided by itself. Now, you can start messing with it. And if the I, 1 divided by I is I to the negative first, which you then have to rationalize because it's a radical.
Wait. What did I just say?
We're getting there. Literally, that's how we're going to have to deal with B. Okay. I would rewrite this as I to the 36 by I to the 3rd, because that's a multiple of 4. And I would turn that into I to the 4th to the 9th by I to the 3rd. Right? I'm looking for multiples of 4 because I to the 4th is 1. That's where I can cancel stuff. So this is just 1 times I to the 3rd.
No, I haven't won.
Yeah.
So my entire class cheated through like all of chapter 5 and everything else too.
Were you in works class for
Yes.
you were in that group?
With the substitute for like half of the semester.
Oh dear
and
God.
then everyone
Okay.
cheated through everything, and then
So
I taught myself algebra too. I'm just gonna say
the
that.
combination of we now have a college algebra class and some kids just fear for GPA, so they want to go take that. By the way, taking college algebra from a first year college algebra instructor. We'll see how it goes. We've got kids doing that, but in addition, we also have, there was a big chunk of kids that just cheated their way through Algebra 2 last year.
And they didn't even get the. Here's the thing.
No,
They had
I know,
four
I know.
points before the penalty. They cheated
I
on
know.
someone that also didn't know how to do it.
And last year, I told my PreCalc classes to go be emissaries for me and tell everyone from those classes, hey, you don't know the prerequisites to be in this class. You are going to get hurt if you come up to PreCalc not knowing how to polynomial. That is why we have such low rosters this year. Okay. Also, we were really close to being 2 sections of PreCalc instead of 3. So because it's spread out into 3, all of our classes are small. My afternoon PreCalc right now is 10 kids. It's tiny. It's tiny. And then there's always the kids who register for it and then they get hurt in Algebra 2, so they decide not to take it. Or they get a D in Algebra 2, so they can't take it. So 1 by I to the 3rd, since I to the 3rd is negative I, it's just negative I. Let's see, who remembers? What does a negative exponent do? Reciprocal. Turn to a fraction. If it was upstairs, now it's downstairs. If it was downstairs, now it's upstairs, right? The reciprocal. So this is 1 over I to the 18th. So let's start our long chain here. If I am at I to the 18th on a denominator, that was a tiny 1. 1 over I to the 18th. There we go. Is 1 over, we still want our multiples of 4. We're getting there. Okay. This would be I to the 4th to the fourth, 4 by 4 is 16, with another I to the squared left over. Right? Altogether, 18. Well, this is just 1. 1 to the fourth is just 1. I squared is 1 times -1 is -1. Ta-da! That one ends up nice because it was an integer.
Oh my goodness.
Meaning this was an integer. What happens when it's a radical? Y'all remember, no radicals downstairs. They stir up the kids, give them bad ideas. You can't have a radical on denominator. So what happens when evil math teacher comes along and says, let's make that I to the -23rd? Let's see what you can do. Remember, no radicals downstairs. That also means no i's downstairs. How can you rationalize your denominator? Yeah.
What was the rest of it? I have a killer migraine and I can't even look at the board right
I got
now.
it.
What was the rest of this? Because I was starting to get there and then I forgot that 4 times 9 equals 36. Like I
It
had to
happens.
do that in my hands.
Brain fart. I to the fourth is 1.
Mhm.
So this crosses out and it's 1 to the 9th,
Okay, so
which is,
1.
yep. Are you a write every step out person or are you
I need to look
okay.
later. And I know what third is going to be.
Just times a -I, yep. And since 1 to the 9th is 1, 1 times -I.
Why is this evil? Like,
And so it's just -I.
Yep.
I by -5.
but why can't we do it? It's literally just a 22.
Because you erased it before I got the.
Okay. It stopped me. I want kids to stop me. Okay. For anyone who hasn't been in here before, I think I talked about like remind. I want you to ask questions on remind. If one kid asks a question,
Isn't I times -I?
Are you morally opposed to getting something wrong?
what's that? Artificial expectations of perfection?
What is I times -I?
-I squared.
-I.
I times a -I.
Then the answer is 1, right?
No.
No.
Yes.
Let's take a.
Yes.
Oh wait.
Is it positive or negative?
The answer is just I.
Why is it positive?
Just put it back out times the negative.
Okay.
Oh, we got I.
I got 1 over -1.
All right. The ADHD train got derailed. Y'all, if I'm ever writing stuff up here and you are copying it down, if there's something that we wrote, something that we did that you don't understand, your educational process gets better the more you interact with it. Stop me. Stop me and say, whoa, 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 don't erase. Where'd that 5 go from? Okay? I want you to stop me. I want you to interact. I want you to ask questions. You all know what it's like if you just space out in class for 10 minutes. Aren't you? You might be able to kind of figure out what's going on after that, but don't you still feel like you're chasing the bus for the rest of the class? You're just a little bit off. Okay? That little bit of clarification is the difference between I've always been able to get it and it's been easy versus now I got to think more, I have to engage. Okay? Stop me. Ask questions. That is important. All right. Whoa, get up there. There are 2 ways to do this problem. Option number 1. Negative exponent means downstairs. Well, cool with that? Break this up the same way we were doing the other ones. So I'm going to call that 1 over I to the 20th times I to the 3rd. We're all like, all right, so far. Well, I to the 20th is I to the 4th to the 5th. Because I to the 4th is 1, 1 to the 5th is just 1. Well, they don't cancel because I still need something on the numerator. Just bear with it. Okay. What is I to the 3rd?
Negative I.
Negative I. And we might think that we're done there, because that is now 1 over negative I. But I can't have an I can have negatives on denominator. It's considered, it's more of a like, T'Challa, we don't do that here thing where, no. This is 1 over negative square root of negative 1. I can't have a radical downstairs. How do I rationalize to get radical off denominator? Multiply top and bottom, numerator, denominator, by that same thing. So I take this times square root of negative 1, or I, it's the same thing, getting 1 times square root of negative 1 is just I. Square root of negative 1 times square root of negative 1, or I times I, is I squared. So this is a negative I squared. And yes, Doyo, that is a negative 1. Which is just I. Okay. Now, here's where we all get upset. This is how I would have to do it if I am purely thinking in terms of exponents and radicals. But if I remember that it's a ring, and I can keep going around that circle any number of times, just like multiplying by 1 doesn't change an object, just gives it a makeover. Like if I multiply by 4 over 4 or something. I can also multiply by iterations of I to the 4th, because I to the 4th is 1 lap around the ring. So then I show you this thing and everyone grumbles and groans. I to the negative 23rd. What if I just took that times I to the 24th? Because I to the 24th, 24 is divisible by 4, right? So I to the 24th is 1. Anything times 1 is itself. So I'm not changing its value, I'm just giving it a makeover. And bases that are the same, what do I do to exponents when multiplied? Negative 23 plus 24 is 1. Ta-da!
That's the worst magic I've ever seen.
So now, after having seen the trick, I want you to think about, what if I said I to the negative 39th? What is a positive exponent multiple of 4? I take that times I to the 40th, because that is 1 to the 10th. So I would just call it I. What if I said I to the negative 233rd?
What do you mean this is 2?
236. Times I to the 236 is I to the 3rd is negative I. Because 234 isn't divisible by 4. Remember, 100 is divisible by 4. So I just look at the last 2 digits. So I need something more than 33 to get into positive town. I don't want to go all the way to 40, because then I would have I to the 7th, which is a little too far. I'd have to back up. Yeah, you can still do it. And you can work forwards or backwards through the ring. It's like, I don't know, Dr. Strange with his, I'm tilting the wheel and just looking at the timeline. You can go back or forth, it doesn't matter, all the way through. That ring is just multiples of 4. You're only going to be in one of those 4 positions. I tried showing this to my Algebra 2, and their brains broke, so I just moved on. Yeah, I tried. I started to talk about it, and kids' eyes glazed over. I'm like, we'll get you in pre-calc. So, didn't know that there was that much going on with I, did you? It's imaginary. See, it turns out you can play with imaginary numbers. Just like imaginary friends. Complex numbers, I talked about this yesterday with number sets. A complex number has a real part and an imaginary part. Which is how I'm going to be able to work with it algebraically. A complex number has a real part and an imaginary part. If it's a pure imaginary number, a world of pure imagination. If I have a pure imaginary number, that means there's only an imaginary part. To be a complex numbers are written in the form a plus bi. Real part, imaginary part. Real friends, imaginary friends. So a complex number would be something like 5 plus 2i. It has a real part and an imaginary part. It's complex. That'd be like if someone has imaginary friends and I ask you, who are your friends you're inviting to your birthday party? And they say, it's a little complex. Okay? Now, if you have a real number or a pure imaginary number, they do still fall under the umbrella of complex numbers. How can I turn just 5 without changing its value? How can I turn that into a complex number with real part and imaginary part? But if I add an I, I've changed its value. That's a 1. Okay, we're starting to wiggle around with it. Good. Real part plus coefficient I. The additive identity says if I add 0 to a thing, I don't change its value. So 5 plus 0i is still just 5. What if I had a pure imaginary number like 2i? How could I turn that into a complex number? I add 0 real parts. Okay? Like, I argue with kids about that. 0 is a number, stop hating. Okay? This is why in Algebra 2, after you learned what imaginary numbers were, dial back. When you learned what imaginary numbers were, that's when you started getting all those polynomials, and they would say, solve for all complex zeros. That didn't mean that your zeros were all going to have i's on them, because 5 is still a complex number. 2/3 is still a complex number, because right after it is 0i. Okay? Now, because they follow this pattern of a plus bi, and Doyle just said it perfectly, I can treat I just like any other variable. That means I can start to do operations with complex numbers. Okay. If I am adding or subtracting them, it's as simple as combining like terms. 5 plus a negative 2, and negative 3i plus 4i's is 1i's.
Oh, okay, never mind. I paid attention.
Reading the card explains the card. Okay. For multiplication. You multiply however you're going to multiply. Maybe you're a spaghetti monster kind of person. You like drawing the arrows. 2 times 7 is 14. 2 times negative 4i is negative 8i. Negative 3i times 7 is negative 21i. And negative 3i times negative 4i is plus 12i squared. The catch is that when I combine like terms, I have to remember. I plus I is just more i's. But what is I squared? Negative 1. So I have to change this. This is now 14 minus 29i minus 12. You're not done combining because I squared is negative 1. So now it's 2 minus 29i. Now when I said you multiply however you want, okay, this is draw the arrows, do the spaghetti monster. Who's a foil fan? Like you actually think first, outer, inner, last. That's just these arrows verbally instead of visually. Who's a, everyone in here is sophomore or higher. Who's a Punnett Square fan? Okay. Who writes theirs out as 2, negative 3i, 7, negative 4i? Because 2 times 4 is 14. 7 times negative 3i is negative 21i. 2 by negative 4i is negative 8i. Negative 3i by negative 4i is, whoa, wrong one, 12i squared. Okay. It just depends on how you prefer. Okay. There you go. Because I'm multiplying them. If you do this and you have your binomials or trinomials or higher, if you have those arranged by descending order, if they are organized, then your like terms are always going to be on diagonals too. Okay? What about old school stack multiplication? I showed my algebra 2s this. Do you know that multiplying long chain polynomials is just basic multi-digit multiplication you've been doing since second grade? That 2, negative 3i, 7, negative 4i, if I just multiply those together, well, negative 4i times negative 3i, 12i squared. Negative 4i times 2 is negative 8i. 0 as a placeholder, move on to the next one. 7 times negative 3i is negative 21i. 7 times 14, or 7 times 2 is 14. And then everything is lined up by like terms, because like terms in polynomials are just place value in regular numbers. You've been doing distribution since you first learned how to multiply. So you do it however you do it. I don't care what your format is. I just care that you follow math law. Okay? Those two. I do two, you do two. I'm sure some of you already done them, but yeah.
I get this very good.
0 divide constant 5, 1 minus 4 plus 5, yes, 5. So there's 5 plus 6, 11 is negative 10, negative, oh, negative 10, negative 3, negative 13i.
Wait, chapter 5 has big important ones.
Wait.
Yeah, so I realized in my grade, because I taught myself the entire thing through the textbook. It's been so long since I've listened to any type of lecture for math. And I realized that my grade was high enough that I could just not take one of the unit tests and I would still keep my A.
Oh boy.
And I bet you couldn't guess which one it was because I was gone for COVID.
Do you distribute that? Like, woo!
Distribute the negative one, then combine like terms. Yes.
Okay, I was gone for COVID, so I wasn't there for that unit at all. I turned in that homework 3 months late and then didn't take the test ever. You messed up on 5.
Well,
So I can have this on 5.
buckle up, Buttercup. Now, most kids, if I said subtract this stuff, I see kids say 10 minus 14 and then negative 2 minus 6i like that. Okay? Because we forget it's minus a negative 6i, right? So if you get caught in that trap, if you just forget that the negative carries all the way through because you're subtracting, please distribute a negative 1 first. Like that. And all the way back to, I have like algebra 0.6. I always tell them every time you run into a plus or minus, it's a new term. Combining like terms, you can just chop it up like this and then sort your Legos. Okay? I's go together. Not i's go together. This was a positive, so I put plus. Okay? So if you need to distribute the negative into it so you don't screw up the signs, y'all, if you're in pre-calc, you know you are veterans. You are battle-scarred warriors. You know that negative is the bane of the math student. How many times have you gotten to the end of a page of work and you missed a negative up here in step 1? Right? Wait until we get to matrices. Okay? Matrices, if you do it correctly, you can do it in 3 steps every time if you're willing to work with fractions and multiple step operations, but you're looking at a minimum of 40 calculations per problem, but they're all just simple arithmetic. Yes? All right, these two, they got a special name. For everyone who just came out of Algebra 2, what is it called when the binomials are the exact same thing, but I change a sign in the middle?
I don't remember the name, but
Conjugate. Okay. These are called conjugates, and we are going to use them when we divide because they're how we're going to eliminate the I entirely. We'll see that again, yeah. 4 by 4 is 16. 4 by negative 5i is negative 20i. And for folks who haven't been here before, you're going to start seeing when I distribute like this, I like to automatically organize things by like term. I move down to my next row and say plus 20i like this, and then continue. Because if I do it in tiers like that, I can just make sure that my like terms are always organized. These are conjugates, which means my middle term is always going to cancel out. And now that we know that I squared is negative 1, this is really plus 25, so smack them together and you get almost the meaning of life. You cool with the multiply stuff? Like, this should all, again, be review. You did all of this with basic radicals back in Algebra 1. Okay. We're going to use that idea of a conjugate to, it's called rationalizing my denominator. It's how I divide with i's. Remember that i's are square roots. So if I have 5 minus 3i over 1 minus 2i, and you know that you're not supposed to have a square root on denominator. And we remember that if I had something like, I don't know, 8 over square root of 3. Y'all know you got to do this, right? Well, if I have to do that to rationalize things, you're going to get that kid who says, all right, I know how to do this. Get wrecked times I. And what happens? You just get another I. You're like, okay, well, now I've got I plus 2. All right, I know how to get rid of that. I'll multiply by I. And you're like a Yorkie chasing your tail. You don't even know what you're going to do when you get to the end. So I multiply by conjugate.
I mess this up as well, but where did you get that?
Distribute. Be careful with your signs. Up top, 5 by 1, 5 by 2i. Negative 3i by 1, negative 3i by 2i. Downstairs, 1 by 1, 1 by 2i. Negative 2i by 1, negative 2i by 2i. Make sure you have your distribution done correctly. After the distribution, we say, oh, hey, I remember. I squared is negative 1, so I turn this to plus 6. I squared is negative 1, I turn this to plus 4. And these two will always cancel out because they are conjugates. Do not just yeet the whole denominator out of there. I get some kids who will do this and then just not write the denominator. Like, that's freshman math, okay? The denominator is still there. It just changes to not include i's anymore. So up top, I have 5 plus 6. 10 i's minus 3 i's. Oh, we missed a negative over there. You had 7i originally. That was right.
I was going to say, I did it again.
Did you? I think you had a negative on here when we were doing the problem. Or I might have just read it as a negative. Okay, that's on me. Slightly cross-eyed. Sleep deprivation make eyes go wee. Right? 1 plus 4 is... Doyo is well aware of this. You were right. Yeah. This is not the final answer, though. Okay? Now, you've heard that enough times because you just came out of 4 months in Algebra 2 where I kept saying, separate your real friends from your imaginary friends or you're not going to have any real friends. You have to separate the real part from the imaginary part. I need that to be 11/5 plus 7/5 I. You can write it as 7i over 5, but this is considered more proper. The reason for this, it's a complex number, so if the directions say write your answer as a complex solution, you need to write it in A plus BI format. And year after year, I will have kids who take Algebra 2 or PreCalc. They go on and do a dual credit math class, which involves a lot of computer work. Having to type in your answers into like D2L, Blackboard, something like that. And I have kid come and just slam their laptop down on my desk and say, why is this wrong? I have done this problem like 4 times. I know what this is. Why is that wrong? Separate your real friends from your imaginary friends. And then they'll table flip because it's the exact same thing. It's the same value, but you have to put it in the right format. Okay? I'll take both. I don't care. But some crotchety math professor is going to care. Or if the directions on the test say write it as a complex number, now I care. All right? If you got to make a note about that, do so. All right, just enough time for those 3, and we'll cut it off there.
Is that what a reciprocal is? Would it be a 3 minus 4i? Would that be the reciprocal?
Reciprocal is the complete
The conjugate.
Yeah.
Yes.
Okay.
Reciprocal is the complete opposite, right?
No, reciprocal is you flip numerator denominator. You might be thinking of inverse. And we're going to talk about that when we review inverses. It really, really bothers me that they use the same symbol. This means reciprocal because it's on a value. This means inverse because it's on the name of the function.
I hate functions.
You were in the wrong class then, because that's kind of our first 2 units. Maybe if I just put enough salt on it.
I don't understand letters, man.
And remember, y'all, I want you to be comfortable in here. When you are working on something like this isn't a test. We're set up like a Senate chamber for a reason. Like, I want you cross-talking. I want you checking with people at other tables. Have a conversation about it.
This is fun because I'm right.
Dude, you're going to get decked in this class. Like,
What do you mind me?
Nora's just going to, like, Beavis and Butthead backhand you. Smack! Shut up, Beavis!
Is this negative 6i?
No, it's just 6i.
No, but like the conjugate.
Oh. Conjugates are when you have a complex number with a real and imaginary part.
Oh, so then how do we be?
What's the real part?
4,
For the denominator?
6,
No.
0.
0.
0.
0 plus 6i. So what is the conjugate of that?
0 minus 6i.
Can both of those be simplified?
I don't know.
What is 0 plus 6i?
6i?
What is 0 minus 6i?
Negative 6i.
You are right, but you needed the journey to understand why.
Okay.
I don't speak. Yeah, you put that in the 45. Where'd you get 45? I'm asking something about.
I wouldn't trust me ever.
No, I would.
Maybe we can do that
Where did 36i squared come from? That's a horrible
Minus 49. And plus 49, 104, 115.
Wait, but you
All right. 3 over, what's that?
No, okay. Teaching yourself sucks because then you don't know other perspectives. I'm a prime example.
Okay.
I can't understand her work.
First and third ones I have. Did I goof? I'm tired.
I got 113 as well.
113? Oh, yeah. Basic arithmetic. Oops. Yes. You go over there. Okay. Oops. For this one, you could use the conjugate that right now it says 0 plus 6i, so I'll use 0 minus 6i. But remember, this is no different than like 3 plus x over the square root of 2 times 5. Remember, radicals aren't allowed downstairs. He's cool, I know his dad. Radicals aren't allowed downstairs. 6 is cool, I know his dad. I don't have to multiply by the 6 because at the end, didn't you end up reducing by 6 anyway? The only thing I actually need to multiply by is I. Work smarter, not harder. And then I squared is -1, so this becomes 4i plus 1 over -6. Separate your real friends from your imaginary friends. That's -1/6 minus 2/3 I. Okay. Oh, marker. Marker. You got me. I told you they're going to keep coming. I got fan club out there. I got a fan club out there. Thank you, sir.
I wasn't looking. I wasn't focused. It's still the right answer.